So today we have our Leetcode daily question, which is the number of smallest unoccupied chair. There is a party organized with n friends. The indexing of friends start from 0 to n minus 1, and we are given infinity number of chairs, and chairs number also start from 0 to infinity. Whenever a friends arrive in a party, they sit on unoccupied chair with the smallest number, which means that if there is chair number 0, 1, 5 in the party, then 2, 3 and 4 are vacant, and he will sit on the least number of chair, which is 2. So when a friend leaves a party, that chair become vacant again, and and if another friends arrived, he will sit on that chair which is vacant and least number. So we are given an array times which will contain arrival time and leaving time. We will have target friend, and it is made sure that the arrival times are always distant, and we have to return the chair number that the friend number target is will sit on. So we are given target friend, so we have to return the number of chair on which he will be sitting. So I will give you a quick example. Example number 1 is this. We are given an array of time, which means we have 3 friends arriving, 0, 1 and 2. First friend will arrive at 1 and leave at 4. Second friend will arrive at 2 and leave at 3. My second number of friend will arrive at 4 and leave at 6. My target friend is 1, which is this one, and I have to tell on which seat number he would be sitting. So if we look at this timeline, which is starting from 0 and going till infinity, and this upper part is for example number 1, it says that 0th friend will arrive at 1. The 0th friend arrive at 1 and leave at 4. Then my number 1 friend, this number 1 friend will arrive at 2 and leave at 3. Then we have number 2 friend, which will arrive at 4 and leave at 6. So we have to, my target friend is number 1, which is this one, and I have to tell on which seat number he would be sitting. So my 0th friend comes and I give him a seat because there is no seat till now. So 0th friend will have 0th seat. My first friend will be on first seat. Forward, if the question would be my target friend is like 2, then at this point of time 0th friend would leave, and this 0th chair would be free. So my second friend would again sit at 0th number of chair. But for this example, the answer is 1. So now example number 2, we have our 3 friend number 0 arriving at 3 and leaving at 10. We have our first 1th friend arriving at 1 and leaving at 5. We have our number 2 friend who comes at 2 and leave at 6. My target is 0, which means that my 0th friend arrive at 3 and leave at 10. Then my first friend comes at 1 and leave at 5. And then we have my second number of friend who comes at 2 and leave at 6. My target is 0, which means that 1 seat will be arrived to him. Second seat chair number is again started from 0. 0th chair is arrived to 1. First chair is arrived to 2, and to 0 my second chair will be assigned to him. So how we gonna solve this question? Looking at the question, we come to a conclusion that either a chair can be available or it can be reserved. If someone is sitting on it, we are reserved it, and if someone leave, that chair is available to be occupied by someone else. So whenever a friend arrives, we have to do either of the two things: assign him the smallest available chair. Like when a friend comes into the room, if there is an available chair with the smallest number, we will give it to him. Or if there is no available chair, we will reserve a new chair to him, and we will keep track of that chair number and when he gonna leave that chair, that what is the departure time of that friend whenever a new chair is being assigned to him. So to track these two things, we will have one min heap, because we always want the smallest available chair. For that we will have min heap, so it will gonna track the available chair with minimum number. The second is a min heap of pairs, which is gonna store departure time and chair number. It will be saving the minimum departure time at top of it. So now I'm gonna give you a dry run to how solve this question. So for the dry run, I have taken the example number 1, and the target will be friend number 2, and the answer should be 0, that he will be sitting on the 0 number of seat. What we are gonna do is, we're gonna save the target friend arrival time. Why? Because it is given in the question that it is a unique value, and this is gonna be used to identify the friend. Step number 1 will be, we're gonna sort the arrival time. We're gonna sort the array according to their arrival time. Then what we're gonna do is, we will iterate over this array, and which means that one of my friend has arrived, I will check, is any seat available over there? No, there is no seat available. We will provide him one seat. So chair number 0 will be, and the chair number will be assigned according to the reserved dot size. So we will provide him a seat, and we will keep track when he gonna leave. And then my second friend will arrive. We gonna check, is it the time when he arrives? He arrives at 2, and the last out time is 4, which means that the last friend will leave at 4, but my new friend has arrived at 2, and there is no available seat. So we are gonna provide him one more seat. So the seat will be assigned according to the reserve size, which will be 1, and we're gonna save the departure time of our number 1 friend, which will be 3. Now what we're gonna do is, we will check whether we will move to the next friend. So its arrival time is 4, and my departure time of the last friend is 3, which means it's gonna depart. So what we're gonna do is, we will move the chair from reserved to available. So this 1 will be moved over here, and this whole will be removed. And then we're gonna check again that is the reserved empty or not. It is not. Is the arrival time is less than or greater equals to the out time? So yes. Then again we're gonna move this 0 number of chair over here. 0 will come over here, and this is gonna be removed. And then we will check that is this 4 equals to our arrival time? Yes, it is. So we just gonna break our loop, and at last we will check if our available is empty. We will return the size of the reserved, and if it is not empty, if available is not empty, then we will return the available stop, which will be 0. So this is how our code gonna look like. So this is our size of array. We save our target friend arrival time. We have 2 min heap, one is available and another is reserved. We sort them according to their arrival time. Then we iterate over this whole times array, and then we make sure that if our reserved is not empty, and reserved top first is less than equals to t.0, which means that this is the arrival time of new friend, and this is the departure time of my last friend. If these both conditions satisfies, we're gonna push in the available and reserve will be popped, which means this is the step we were doing over here, that we are taking from here and we are moving to this part. And then we check that if our target is equals to our arrival time is equals to our target friend, which means this condition satisfies. So we will gonna break if available is empty, which means that my friend have arrived and we don't have any seat for him, so we're gonna just reserved one more seat for him. And if available is not empty, which means there is a seat available, so we will just provide a available seat, like a seat will be moved from available to the reserved, no new seat will be given to that person. And at last, when available is empty, we're gonna return reserve size, and if it is not empty, we will return the top of available. So this is how we're gonna solve this question.